Hi everyone. In this video, we can discuss about differential pulse code modulation. Previously, the PCM technique was mostly used. It has more redundant information behind it. So, we have to reduce this redundant information. We can have a decision to have a predicted sampled value along with previous output and summarize them with the quantized values. Such a process we call it as differential pulse code modulation. Basically, the difference between the samples alone modulated using differential pulse code modulation. We move on to block diagram. This is the block diagram represents the differential pulse code modulation. It has a summer and a quantizer and a predictor. We have two inputs to the summer circuit. One is the sampled input, another one is the quantized x cap of NTS. And the difference between the sampled input and the predicted input is called error signal E of NTS. And the output of the quantizer will be V of NTS. Here the predicted previous output is added with the present input of the quantizer, and this will take a new input for the predictor every time the predictor to be updated, that is U of NTS. Take an example. Here we have a signal. So this analog signal we want to convert it into digital with the less number of bits. We compare with the PCM. DPCM takes the representation of bits will be half the bits what we have used in the PCM. For example, if I sampled this particular signal, I have taken the samples from the input. The different amplitude discrete values are noted here. That is my input of this particular summer. The first sample I will consider 1. 1 is my present input and the x cap of NTS is no, there is no any signal. Therefore, only the data 1 is get applied to the quantizer. So the quantizer output 1 is converted to digital. So my output will be 1. The same 1 will be applied to the second summer and given as input to the predictor. So now the x cap of NTS also 1. So after the incident, we have a second input called 4.2 volt. So now my input is 4.2 with the subtraction of x cap of NTS. So always the formula is the error signal will be the subtraction of x of NTS minus x cap of NTS. Therefore, now the result is 4.2 minus 1. So the difference will be 4.2 minus 1. So we will get a 3.2. So that 3.2 only applied as a input to the quantizer. Therefore, the quantizer will convert this 3.2 into integer as 3 and the corresponding output is delivered as equivalent to 3. The same time the 3 is given here and the previous x cap of NTS is also added here. Therefore, the result is now 3 plus 1. So we have the input is 4 to the predictor. Now the predictor is updated to the value 4. So I can change my predictor is 4, that is x cap of NTS. And now I will take a new input that is 5.1. So my present sampled input is 5.1. So this one I am considering now. So again we take a difference, 5.1 minus 4. So we have around zero point 0.9. So the integer will take it as integer 1. Nearest integer is 1. Therefore, again there is a output will be 1, and the same output is applied to the summer here. So previously I have the value is 4. So these two are get added. So my result will be 5. That the predictor is now updated to 5. Therefore, so my x cap of NTS also now it is updated as 5. What is my next input? My next input is 4. Therefore, you compare with this previous x cap, it is a lesser value. Therefore, the formula is for calculating error x of NTS minus x cap. So in this case, so you will get 4 minus 5. So the result will be minus 1. So the minus 1 is quantized. So the representation here is minus 1. So in the similar fashion, the next sample we have, it is a minus 1. So my previous value is plus 5. What is my updation of a predictor? 5 minus 1, we will get 4. So the predictor is updated to 4. And what is my present input? My present input is 3.2. So now make a difference again. 3.2 minus 4, it's around minus 0.8, right? So that is quantized approximately to again minus 1, right? This is the way my DPCM output will be quantized. So each value it is a digitized one, okay, because the purpose is to make it a digital value. Similarly for 3 you may get 0 0 1 1. Likewise, this is the bits we want to transmit it, okay. So this one we have to transmit through air, and after that we have to receive in the receiver back, okay. So here x of NTS is the sampled input, x cap is the predicted sample, E of NTS is the error, and V of NTS is the quantizer output, and U of NTS is the input to the predictor. So here the V of NTS will be the quantized value of my input, and U of NTS is the combination of the previous predicted value x cap of NTS plus the present value of V of NTS. So that's the equation given here, x cap plus V of NTS. So now we move on to DPCM receiver. This is the DPCM receiver we have. So the input is B of NTS. That's basically a binary wave, right? The previous transmitter corresponding to transmitter, the datas are get converted according to the transmission, right? If it is 1, so we have a 3 0 and 1. This is the binary wave you have transmitted consecutively. Next 3 will be transmitted, and 1 minus 1, like that. So these waves are available now to the receiver. What are all the values we have? The first one is 1 1, then we have 3, and again 1. Next is there will be a 2 negative ones, 2 negative 1. This is the sequence. So first the bit 1 to be applied as a input. So the decoder will convert that the corresponding waveform into the data. So now you consider the input to the summary is 1. So there is no previous output. So here also we have a predictor. So the first case nothing. Therefore 1 is directly given as an output, that is called U of NTS in this receiver is concerned. DPCM receiver is concerned, we have the output is now 1. And after that, the same 1 is given to the predictor for the updation. So now the x of NTS will be 1 and the v of NTS is the next sample. What is the next sample? We have 3. So the input to this is 3. So now these two are get added. 3 plus 1. What is my result? My result is 4. And after that we have 1. So now this 4 will be updated in the predictor. So x cap of NTS again in the receiver is 4. So my present data is 1. Present data will be 1. So you may get 4 plus 1, 5. And this 5 will be updated in the predictor in the next sample. So my predictor value is now 5. So what is the next input we have? It is minus 1. Therefore, just to add it, so 5 minus 1, you may get 4. So after that again there is a minus 1. So this result of 4 will be updated. So my predictor output is now 4. So there is again minus 1 the data. Therefore the result will be 3. So you can plot based on these values. So my output will be here. The first sample you have to plot in this side 1. Next will be 4. After that we have 5. Then again there is a 4 and it is 3. Yes, this is the data what you have transmitted in the transmitting circuit approximately. So 1, 4, 5, 4, 3 back. Okay, so this is the way you have received the data again back. 1, 4, then 5, there is another 4 and 3. Okay. So this is the system, differential pulse code modulation and demodulation system. Your input sample data again it will be decoded back to bring your original sample data. Then after this we have a low pass filter to reconstruct. So after you joining all the pulses you may get back the original signal back. So that is you want to transmit it from the DPCM transmitting circuit. Thank you for watching. Thank you.